In this lesson, we are going to explore a alternative and much more popular method of handling side effects in Redux using a library called Redux Saga. But before we do, we're going to take a deeper dive into what it is these asynchronous libraries actually do. So we've already explored our Redux Thunk, where we can pass a function that allows us to dispatch inside of it, and then Redux will handle actually firing these multiple actions that we write. But what's actually happening is that inside of our Redux, we have this Thunk library that we apply as a middleware. And this Thunk is what allows the Redux store to dispatch functions instead of just actions or action objects as we're used to seeing. Now, how does this actually work? Well, when we go back to our diagram of Redux, just a quick refresher. We have our root reducer, which represents our application state. And it's composed of all these other reducers. We pull state off of this and pass them into our respective components as props using selectors. These components then fire actions, and these actions will then update the corresponding reducer. So this flow we're already incredibly familiar with because we've written it a couple times now. So now hopefully this flow makes a lot more sense when we look at it. But what do libraries like Redux Thunk middleware actually do? Well, if we go over to this image, this is a bit of a more simplified flow, except it includes now these middlewares, as well as our sagas. But for now, just ignore this portion of it. As we see, we have components that dispatch actions, and what happens to these actions before they actually make it to the reducer is they hit these middlewares. And these middlewares include our thunks, they include our sagas, and they also include Redux Logger. Now, as we remember in our code base, in our store.js, what we do is we actually apply the logger into our middlewares array, and then we apply the middleware. Same with our thunk, and same with Redux Saga when we bring it in. We're going to have to put it into these middlewares in order for our store, when it's initiated, to apply it into its middleware. But what's actually happening is that before an action gets passed to the reducers for it to update, these middlewares will take it and possibly perform some modification or do something. Whatever we want to write with middleware or whatever these libraries do, the main idea is that middleware catches the action before it hits the reducer. In fact, it's possible for middleware to catch actions and then throw them away so that they never actually reach our reducers. Completely possible. What Logger does is it simply catches the actions and it logs out data using console.log, and then it shows the format of what our state was before the action and after the action. And that's all Logger does. It's able to just catch actions before it hits our reducers and then log it out. Now, thunks are pretty much just a piece of middleware that allows actions to come in as functions, and then if it's a function, the thunk will just invoke the function. Because we have dispatch in the function, thunk will just pass those new dispatched actions into the reducers as we did in our thunk function, right? We pass this function that has two dispatch calls, right? First our fetch collection start, and then after our collection ref.get resolves, we dispatch another action. Well, when we pass this action into our middleware, right, because the action comes in as a function, well, thunk will take it and say, oh, this is a function. This isn't an object. This isn't an object with a type and a payload. What I'm going to do with this function is I'm going to invoke it. The moment I invoke it, whenever I get a dispatch inside of this action function, I am then going to dispatch the actual action that comes out of each dispatch call whenever it happens. So the thunk comes in, right? Our function comes in. It sees the first dispatch and it passes that action in. And then it calls the get to our Firestore. It comes back with the data after a certain amount of time, right? And then it calls the second dispatch, and then it dispatches that new get collections success call into our reducer. So that's all the func middleware does. But sagas are different. We're going to explore the code of how sagas work because it's definitely new concepts. But conceptually, I just want you to think about one thing with sagas so that we understand why we write the code the way we do. Now, the way you can look at a saga is like it's a function that conditionally runs. And the condition that it depends on when it runs is based on whether or not a specific action is coming into the Saga middleware. So imagine a function that is listening for our fetch collections start action. Unless that action fires, that Saga does not execute, i.e. that function does not execute. The main idea with sagas is that there can be multiple sagas listening for multiple different actions or the same action. But they're just pieces of code that do not run until they hear the action that they're listening for. When they do, they can do all kinds of logic. So they can trigger other actions, which go back into our middlewares and continue into our reducers. So other sagas can also be listening for actions that come out of sagas. Or they can render any kind of additional API logic, right? They can go to the backend, fetch some data, use that data, and dispatch actions to update reducers. But the main idea with sagas is that they handle this idea of side effects. And I know that sounds like a fancy term, but we've actually written a lot of side effects already. All side effects are either API calls to a backend, right? So some kind of asynchronous code, or something that triggers an impure reaction. So what is that term, impure? Well, let's open up the console and we can actually explore this concept. Inside of React, we write these things that we've all written numerous times called functions. And we can have a function called add numbers, which is equal to a function that gets two values, and all it does is it returns the value of adding them together. If I call this function add numbers with the numbers 3 and 4, I will always get 7. No matter how many times I call this function, my value will never change because my function is pure. When my function is pure, no matter what, no matter how many times I call my function, as long as the parameters are the exact same, I will always get the exact same output. In order for a function to be impure, it means that if I were to call the function with the same arguments, I could end up with a different outcome. Now, how does that happen? Well, let's imagine that we have some variable called num, right? In fact, let's use a let. Let num equals 5. If I make a new one called add new numbers, right, as my function, that still takes A and B. But instead what it returns is num plus A plus B. Well, theoretically, the first time I call this with 3 and 4, I'm going to get 12. The only problem is that we can now suddenly change the num value to 8. And now, if I call 3 and 4, I get a different value. My function is not aware, nor is it the one that sets some variable of num that it's dependent on to calculate its output. Because the num exists in the scope outside of my function. My function has access to it, and it depends on it to calculate the value it'll return, but it doesn't control it. And for that reason, this function is impure. It has an external dependency. My function is impure because it does not always return the exact same output, regardless of me constantly passing it the same input. But this is pretty much what sagas are designed to handle in our code. Anything that requires us to make API requests or possibly handle something that might be impure, the idea is that you move it out into sagas. Any asynchronous activity that happens inside of our application that is not related to our component state, but rather possibly related to the application as a whole or some part of the application, should be moved into a saga. And that's also why it makes sagas both more complicated, but also extremely powerful. Because we now move some of the features and the way that we've architected our application into these sagas to handle. It gives Redux a much larger responsibility in our application beyond just storing what our state is. It delegates to it more responsibilities related to things that could be impure or related to more and more of our asynchronous activity. Now, I know it's very theoretical, but once we convert our Redux Thunk code over to sagas and use sagas to handle asynchronous and impure functionality inside of our application, you'll see why sagas are so powerful. Now, in the next lesson, I'm not going to write any saga code yet. We actually have to explore the underlying technology of what sagas are built on. So we'll dive into that in the next lesson.